Hi everyone. Today I will continue with the method to evaluate the iterations. Another kind of method to evaluate iterations is iteration by part. So how to use the iteration by part? Today I will interest you to use this. The formula for evaluate the iteration by part, that's when you have the iteration of udv equal uv minus iteration v du. To use this formula, we can put use by the priority to choose that logarithm and polynomial and trigonometry and to use and so on. When you set the u for this formula, where you could derivative of u, so we get du equal something, and another variable you will set dv equal left equal something left, and something left in the trigonometry in the iteration. And for this formula, we use phi v by the iterate. For example, one, when we have the iterations of s psi s ds. So we could set the priority to put that logarithm, but no logarithm in this iteration. So we will choose polynomial that is x, and you will find the derivative of s. You will get du equal f s dash equal 1. So we just write ds. And another form for dv equal something left, and anything left in this iteration. When you choose s for u and some left for dv, so we could set dv equal this. So this formula we have to iterate for the psi x equal minus cosine s, and we use this formula uv minus iterations v du. So we could derive this formula, and uv equal uv that is s multiplied with minus cosine s, and vdu minus cos, the iteration of minus cos that ds uv equal minus s cosine s minus integration of minus cos cosine s ds minus cos. So we did this one, so okay, but we have to iterate to continue to iterate for this formula. So we keep minus s cosine s minus minus negative and negative, so it's positive. Cosine, the interaction of cosine is sine s, and finally we plus c. Let's see. Another example for this is exercise 2. We have the interaction of s square ln s ds. So in this iteration we have logarithm, so we could choose by u equal ln s, and we will find the derivative of this by the u equal 1 over s ds. This formula for the derivative of logarithm is, and another variable we will set dv equal anything left s square ds, and we will iterate. The first row is derivative, but the second row we will iterate this formula. The integrate v equal s. You will integrate the power is s cube over 3. So we can derive these integrations again by formula, the initial formula equal dv. So we can write s cube over 3 ln(s) minus the integration of this and this. But we will continue to iterate for this formula, so we can simplify this before iteration. So we just keep this and minus. We simplify this iteration is equal s square and delete s, yeah, and so we just we get the results of s square over 3, and we will integrate this formula. So it's good. It will be we insert this formula, this answer. So we go minus s square, integration of s square is s cube over 3 and multiply by 3, so it's over 9. Let's see. Yes. And another example 3. For example, we have the integration of s and e power as okay, e e to s, e power to s, ds. Okay. And we will choose for the first variable du. We can see that there are no logarithms here, so we could choose polynomial for u. For u equal x, and we will find the derivative of this ds equal du equal ds, and we could set dv for left, and we will integrate this by v equal fraction of 1/2. We will divide by the number before x, so and we could just keep this formula. This is a formula of e yeah. And we rewrite this formula again by this is equal 1/2 s and 1/2 e power to s minus v du, the integration of v du ds. So because 1/2 is a constant, so we just keep it again, and we just integrate for e power to s, so it's equal (1/2), and the integration of e equal e power to s over 2, and let's see. Then now example for the integration of Sn trigonometry, Sn about trigonometry, and es e upper s ds. So we could set u equal trigonometry size. Yes. So we find du derivative for psi s is cosine ds, and we will set dv for that equal e power to s ds, and we find v equal e power s. We the integration of es is also the same formula, and we will derive this integration equal psi s es minus integrations of es and cosine s ds. And we could and we see that the integration we need to integration by part another time. So we could count for this, evaluate. We just evaluate this, and we will keep this formula. And we also repeat again by that we could use 1 equal cosine s, and we will derivative for du 1 equal cosine s equal derivative of cosine s equal sin s, and dv for the left E power to S ds. So we could find V dV, and we set dV1 and V1 equal E power S, and we will rewrite this. We just skip, and we will change this formula by another formula, minus U1 V1, so it's a cosine S, cosine S E power to S minus the integrations of ES E power to S and minus minus sine S ds. So we could see that the form of integration will repeat again by multiply this. We could see we omit the bracket and we change the formula, and we put this side from the front, so we could get, and we see that this formula is the same for initial formula, so we could change, we move to another, we move to the same right, to by, if we set here by I equal, so we could get this equal I, and we move to another side, so we could get to I equal this, and we divide by two sides, we could get 1/2, and you get this, and finally we could plus C. Okay, and this is final results of integration by trigonometry, combined trigonometry and exponential from integration. This is the first basic knowledge about the integration method, and another video, in next video, I will show the application in solving some advanced exercise. So remember to subscribe for the next video. Thank you for watching. Goodbye.